Section 26 of the Science, History of the Universe, Volume 2. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Science, History of the Universe, Volume 2, edited by Francis Rolt-Wheeler. Geology, Chapter 13. Historical Geology, Part 3. The European Devonian appears in three different facies. One of these is the Old Red Sandstone, which is largely of continental origin and lies to the north. The second facies is of marine, shoal water deposits and runs from Devonshire through Belgium, the northern part of the Lower Rhenish, and the Harz Mountains to Poland. And the third, extending from northwestern France through Germany to Bohemia, was laid down in deeper water. The period began in Europe with an advance of the sea over the land in many places, reaching its maximum extension in the latter part of the period, but beginning to retire before the opening of the Carboniferous. This subsidence removed the barrier which in Ordovician and Silurian times had separated the northern and southern seas, but was accompanied by the formation of closed basins farther to the north. Europe then was largely an open sea with many islands, and where the waters were sufficiently clear and free from terrigenous sediment, coral reefs were extensively formed. The Old Red Sandstone is of particular interest because owing to the peculiar circumstances of its formation it has preserved a record of Devonian land life, which, though fragmentary, is far more complete than anything we possess from the more ancient periods. These strata were laid down in closed basins, sometimes perhaps in freshwater lakes, which had only a restricted communication with the sea, and it may be that these accumulations were partly made by the wind, though there is no gypsum or salt in the beds to indicate the prevalence of desert conditions. The life of the Devonian is, in its larger outlines, very like that of the Silurian, but with many significant differences, which are due, on the one hand, to the dying out of several of the older groups of animals, and on the other, to the great expansion of forms which in the Silurian had played but a subordinate role. The fossils show that in Devonian times the land was already clothed with a varied, rich, and luxuriant vegetation of the same general type as that of whose scanty traces are found in Silurian strata. All the higher cryptogams are represented, and by large tree-like forms as well as by small herbaceous plants. The Carboniferous system of rocks has received its name from the seams of coal, which formed one of its distinguishing characteristics in many parts of the world. Both in Europe and America it may be seen passing down conformably into the Devonian and Old Red Sandstone. So insensible indeed is the gradation in many consecutive sections where the two systems join each other that no sharp line can there be drawn between them. This stratigraphical passage is likewise frequently associated with a corresponding commingling of organic remains, either by the ascent of undoubted Devonian species into the lower parts of the Carboniferous series, or by the appearance in the upper Devonian beds of species which attained their maximum development in Carboniferous times. Hence there can be no doubt as to the true place of the Carboniferous system in the geological record. In some places, however, the higher members of this system are found resting unconformably upon Devonian or older rocks, so that local disturbances of considerable magnitude occurred before or during the Carboniferous period. In Russia, and still more in China and western North America, Carboniferous rocks cover thousands of square miles in horizontal or only very gently undulating sheets. The Carboniferous is divisible into two sharply marked portions, the lower or Mississippian and upper or Pennsylvanian, a distinction which is applicable in all the continents in which the strata of this period have been carefully studied. During this period the interior sea expanded widely, probably covering nearly the whole of the Great Plains and most of the old land areas of the west and southwest, which had persisted through more or less of the Silurian and Devonian, were extensively submerged, probably including all of Mexico and the northern part of Central America. West of the Rocky Mountains, the Carboniferous is much the most widely extended of any of the Paleozoic systems, the sea reaching through British Columbia on both sides of the Gold Range into southeastern Alaska. The remarkable profusion of the vegetation of the Carboniferous period, not only in the Old World but in the New, suggested the idea that the atmosphere was then much more charged with carbonic acid than it now is. Undoubtedly there has been a continual abstraction of this gas from the atmosphere ever since land plants began to live on the Earth's surface, and it is allowable to infer that the proportion of it in the air in Paleozoic time may have been somewhat greater than now. But the difference could hardly have been serious, otherwise it seems incredible that the numerous insects, labyrinthodonts, and other air breathers could have existed. Most probably the luxuriance of the flora is rather to be ascribed to the warm moist climate which in Carboniferous times appears to have spread over the globe, even into Arctic latitudes. On the other hand, evidence has been adduced to support the view that in spite of the genial temperature indicated by the vegetation, there were glaciers even in tropical and subtropical regions. The life of this period is thoroughly Paleozoic and continues along the lines already marked out in the Devonian, but there are some notable changes and advances which look toward the Mesozoic order of things. The Carboniferous vegetation, Scott points out, is of very much the same character as that of the Devonian, but owing to the peculiar physical geography of the times, the plants were preserved as fossils in a much more complete state and in vastly larger numbers. The flora is composed entirely of the higher cryptogams and the gymnosperms, no plant with conspicuous flowers having come into existence, as far as we yet know. By far the most abundant of Carboniferous plants are the ferns, phyllocales, which flourished in multitudes of species and individuals, both as tall trees and as lowly herbaceous plants. Many of these ferns cannot yet be compared with modern ones, because the organs necessary for trustworthy classification have not been recovered, and such are named in accordance with the venation of the leaves. In other cases, the comparison with existing ferns may be definitely made, and these remains show that many of the modern families have representatives in the Carboniferous forests and swamps. In North America, the Permian followed upon the Carboniferous with hardly a break, so that the distinction between the two systems must be made entirely upon the fossils, which change very gradually, by drawing a somewhat arbitrary line of demarcation. In various countries there is no general agreement regarding the upper boundary of the Carboniferous. The lower Permian of Europe is remarkable for the great masses of volcanic rocks, lava flows and tuffs which it contains, and which occur in Great Britain, France, Germany, and the Alps. This is in strong contrast to the corresponding American series, which gives no evidence of vulcanation. The animals and plants of the Permian are transitional between those of the Paleozoic and those of the Mesozoic eras. Here are found the last of many types which had persisted ever since Cambrian times, associated with forms which represent the incipient stages of characteristic Mesozoic types, together with others peculiar to the Permian. The flora of the lower Permian is decidedly Paleozoic in character, and that of the upper Permian is decidedly Mesozoic, so that if the line dividing these two great eras were drawn in accordance with the vegetation, it would pass through the Permian. Even in the lower Permian, however, the change from the Carboniferous flora is a marked one, a change which may be largely explained by the increasing aridity of the climate. Mesozoic formations have been grouped in three great divisions, which, though first defined in Europe, are found to have their representative series of rocks and fossils all over the world. The oldest of these is the Trias or Triassic system, followed by the Jurassic and Cretaceous. The life of the Mesozoic, Scott continues again, constitutes a very distinctly marked assemblage of types, differing both from their predecessors of the Paleozoic and their successors of the Cenozoic. In the course of the era, the plants and marine invertebrates attained substantially their modern condition, though the vertebrates remained throughout the era very different from later ones. Even in the vertebrates, however, the beginnings of the newer order of things may be traced. In the earlier two periods, the Triassic and Jurassic, vegetation is almost confined to the groups of ferns, cycads and conifers, but with the Cretaceous come in the angiosperms, both monocotyledons and dicotyledons, and since then the changes have been merely in matters of detail. Among the Crustacea, the trilobites and eurypterids went out, but all of the modern groups were well represented, though many of the Mesozoic genera are no longer to be found in the seas of today. Insects reached nearly their modern condition so far as the large groups are concerned: butterflies, bees, wasps, ants, flies, beetles, etc., being added to the older orthopters and neuropters. Fishes became modernized before the close of the era, the bony fishes having acquired their present predominance. The amphibia took a subordinate place, and after flourishing for a time, the great Stegocephalia died out, leaving only the pygmy salamanders and frogs of the present. Birds and mammals made their first appearance, the former advancing rapidly to the nearly present grade of organization, though not reaching their present diversity, while the mammals remained throughout the era very small, primitive, and inconspicuous. The most significant and characteristic feature of Mesozoic life is the dominance of the reptiles, which in size, in numbers, and in diversified adaptation to various conditions of life, attained an extraordinary height of development. The Mesozoic is called the era of reptiles because these were the dominant forms of life. They filled all the roles now taken by birds and mammals. They covered the land with gigantic herbivorous and carnivorous forms. They swarmed in the sea, and as literal flying dragons they dominated the air. At the present time there are only 5 orders of reptiles in existence, and of these only the crocodiles and a few snakes attain really large size. In the Mesozoic era no less than 25 reptilian orders flourished, and many of them were gigantic members. Some were the largest land animals that ever existed, and the sea dragons rivaled the whales in size. Nothing so clearly shows that the Mesozoic era is a great historical fact as the dominance of its reptiles. The Triassic period is so named from the very conspicuous threefold subdivision of this system of strata in Germany, where its rocks were first studied in detail and where they occupy a greater area than in any other European country. The German Trias is, however, not the usual facies of the system, but a very peculiar one, and cannot be taken as the standard of comparison for most other countries. In the early part at least of the period, both North and South America extended farther east than at present, and no marine Triassic rocks are known on the Atlantic slope of either continent, but they are extensively displayed on the Pacific side. The land barrier, which during the Paleozoic era had bounded the Great Basin Sea on the west, was submerged, and the Pacific extended over the site of the Sierras, covering western Nevada and sending a gulf into southeastern Idaho, and in British Columbia it transgressed eastward across the present mountains, and it covered part of the coast of Alaska. On the Atlantic side of North America the course of events is entirely different. In the latter half of the period was formed a series of long narrow troughs running closely parallel to the trend of the Appalachian Mountains, but separated from them by the ridges of metamorphic and crystalline rocks which follow those mountains to the east, and which then probably had a considerable altitude, much greater than at present. In those troughs was laid down the enormous thickness of non-marine rocks which constitute the Newark series and are now found in several disconnected areas from Nova Scotia to North Carolina. Triassic life is entirely different from anything that had preceded it, though the way for the change was already preparing in the Permian. The Upper Permian, if classified by its plants alone, would be referred to the Mesozoic rather than to the Paleozoic. Therefore it is not surprising that the Triassic flora is very similar to that of the Upper Permian, though the Upper Trias marks a decided advance among the plants. Among the animals a considerable number of surviving Paleozoic types persist into the Trias which did not pass into the Jurassic. William Smith, the father of historical geology, was the first to work out the divisions of the Jurassic, which he did early in the last century. Smith's name for the system, Oolitic, has been abandoned in favor of the term Jurassic, which was first used by Brongniart and Humboldt. It was taken from the Jura Mountains of Switzerland, where the rocks of this system are admirably displayed. In Europe the Jurassic has long been a favorite subject of study because of the marvelous wealth of beautifully preserved fossils which it contains. For this reason the Jurassic is known with a fullness of detail such as has been acquired regarding very few of the other systems, and no less than 30 well-defined subdivisions have been traced through many countries of the Old World. In this country the Jurassic is ill represented and its divisions are not clear. The life of the Jurassic has been preserved in wonderful fullness and variety, but with comparatively few exceptions our knowledge of it has been principally derived from Europe, where a host of eminent geologists have long studied the great wealth of material. The contrast between North America and Europe in regard to the relative abundance of Jurassic marine fossils is seen from the fact that while in Great Britain alone more than 4,000 species have been described, in America hardly 1/10 of that number has so far been found. The flora of the Jurassic differs little on the whole from that of the Trias, and is made up of ferns, horsetails, cycads, conifers and ginkgos. The name Cretaceous is derived from the Latin word for chalk, creta, because in England, where the name was early used, the thick masses of chalk are the most conspicuous members of the system. Though first made known in England, the main subdivisions of the Cretaceous, as employed in geological literature, bear French names which have proved themselves better adapted to general use. In very marked contrast to the scanty development of the Jura, the Cretaceous strata of North America are displayed on a vast scale and cover enormous areas of the continent, eloquent witnesses of the great geographical changes in that long period. Continental, estuarine and marine rocks are all well represented, and in consequence our information regarding the life of North America and its seas during Cretaceous times is incomparably more complete than it is for the Triassic and Jurassic. It was during the Upper Cretaceous that the great subsidence took place which affected nearly all parts of the continent and brought the sea in over vast areas where for ages had been dry land. South of New England the Atlantic coastal plain was submerged, and in New Jersey at least the waters covered even the nearly base-level Triassic belt, bringing the sea up to the foot of the crystalline highlands. The lowlands of Maryland, Virginia and the Carolinas, and all of Florida, were under the ocean, and the Gulf of Mexico was extended northward in a great bay, the Mississippi embayment, covering western Tennessee and Kentucky, and extending into southern Illinois. In the southern region, the lower Cretaceous was terminated by an upheaval which caused the Comanchian Sea to withdraw from Texas and the area to the west and north of it. This mid-Cretaceous land epoch must have continued for a considerable time, permitting extensive denudation and complete change in the fauna. Wherever the marine Upper Cretaceous is in contact with the Comanche limestones north of Mexico, the two are unconformable, and no species of animal is known to pass from one to the other. In Mexico, the lower Cretaceous passes into the upper without a break, the disturbances there taking place at a later date. The Mesozoic era was closed in the west, as the Paleozoic had been in the east, by a time of great mountain making, and to this movement is attributed the formation of most of the great western mountain chains. From the Arctic Ocean to Mexico the effects of the disturbance are apparent. The Rocky Mountains, the Wasatch and Uinta Mountains, the great plateaus of Utah and Arizona, and the mountains of western Texas date from this time, though subsequent movements have greatly modified them. Vast volcanic outbreaks accompanied the upheaval, which was on a far grander scale than the Appalachian Revolution had been. The life of the Cretaceous displays so great an advance over that of the Jurassic that the change may fairly be called a revolution. In the latter part of the lower and in all of the Upper Cretaceous of North America, the flora assumes an almost completely modern character, and nearly all of our common kinds of forest trees are represented. Sassafras, poplars, willows, oaks, maples, elms, beeches, chestnuts, and very many others. A new element is the monocotyledonous group of palms, which speedily assumes great importance. Cretaceous animals are sufficiently different from those of the Jurassic, but change is not so revolutionary as has been found among the plants. The life of the Cenozoic era is very clearly demarcated from that of the Mesozoic, though many modern characteristics began in the Cretaceous or even earlier. The plants and invertebrate animals nearly all belong to genera which are still living, and the proportion of modern species steadily increases as we approximate the present time. The fishes, amphibia, and reptiles differ but little from those of modern times, and the birds take on the diversity and relative importance which characterize them now. Above all, the mammals undergo a wonderful expansion and take the place of the vanished reptiles, giving to Cenozoic time an altogether different character from all that went before it. The great geographical and climatic changes produce migrations of land animals and plants upon a grand scale, from continent to continent and from zone to zone, the result of which is the distribution of living beings over the earth's surface as we find it today. The Tertiary period witnessed the development of the present distribution of land and sea and the final upheaval of most of the great mountain chains of the globe. Some of the most colossal disturbances of the terrestrial crust, of which any record remains, took place during these periods. Not only was the floor of the Cretaceous sea upraised into low lands with lagoons, estuaries, and lakes, but afterwards, throughout the heart of the Old World, from the Pyrenees to Japan, the bed of the early Tertiary or Nummulitic Sea was upheaved into a succession of giant mountains, some portions of that seafloor now standing at a height of at least 16,500 feet above the sea. During Tertiary time there was an abundant manifestation of volcanic activity. After a long quiescence, during the succession of Mesozoic periods, volcanoes broke forth with great vigor both in the Old and the New World. Vast floods of lava were poured out and a copious variety of rocks was produced, ranging from highly basic basalts, limburgites and periodites, to rhyolites, quartz felsites, and granites. The name Tertiary was given by Cuvier and Brongniart early in the last century to the succession of marine, brackish water and freshwater beds in the Paris basin. Sir Charles Lyell many years later proposed the division of the Tertiary into three parts: Eocene, from the Greek eos, the dawn, and kainos, recent; Miocene, maion, less, and kainos; and Pliocene, plion, more, and kainos, a scheme which is still used today, modified by Bayreuch through the insertion of a fourth epoch, the Oligocene. Oligos little or in small degree, and kainos. Last of all, the lower Eocene has been separated under the name Paleocene. Paleos, ancient, as in Paleozoic, a change proposed 30 years ago by the botanist Schimper, but only lately coming into wider favor. It has become customary to distinguish between the older and newer parts of the Tertiary by grouping together the Eocene and Oligocene into the Paleogene and the Miocene and Pliocene into the Neogene. Section 26.